You're welcome. In this video, I will talk about equilibrium, conditions for equilibrium, translational equilibrium and rotational equilibrium, free body diagram, concurrent and non-concurrent forces, tension, torque, and then I'll solve practice problems. So I'll advise that you don't skip around this video. Basically, equilibrium means a body is at rest. It is the state of rest of a body, or a state where a body is moving at a constant linear velocity or at a constant angular velocity. It all started from Newton's first law of motion, which states that a body will remain in its position of rest, in its state of rest, or if it's in motion, it will remain in its motion but at a constant velocity or a uniform velocity, unless it is being acted upon by a net external force. Notice that in that law, it is only net external force that causes motion. The internal forces are assumed, to have cancelled out. Let's say we have a ball. This ball, okay, this is the ground. This ball will remain at rest on this ground unless you exert an external force on it. So only external forces are able to cause motion. So if we do not want motion to occur, it means that the net external forces must be equal to zero. So this is the first condition for equilibrium. That is, for equilibrium to occur, the body should be at rest, or the body should be moving at a constant velocity. Constant velocity means there is no acceleration. And if there is no acceleration, according to Newton's first law, the net external force is proportional to the acceleration. So if the acceleration is zero, then the net external force should be zero. Hence, this is the condition for equilibrium. Now, it should be noted that this is a vector equation. That is, the vector sum. If the body is not moving, that does not mean there is no force acting on the body. A lot of force might be acting on this body in many directions, but it should be noted that their vector sum has to be equal. The vector sum of all the forces has to be equal to zero for that body to be at rest, or for that body to be moving at a constant velocity or a uniform velocity. So if a body has an acceleration of zero, the body can be moving, but the body will be moving at a constant velocity. The reason is because acceleration is the rate of change of velocity. So if we have a constant velocity, the initial velocity will be equal to the final velocity, and as a result their difference will be equal to zero, so that is zero divided by the time, which is zero, no acceleration. Equilibrium can be translational, and then it can also be rotational. A body is said to be in translational equilibrium when it moves on a straight line at a constant velocity, or when that body is at rest. Also, a body is said to be in a rotational equilibrium if the net torque, that is, the net torque acting on that body, if it is equal to zero. Torque is the measure of the rotational force on a body. It simply means that the body will remain in its initial rotational state, or the body will be rotating at a constant angular velocity. Now, let's say that this is a door or a beam that is attached to a particular hinge and is able to rotate at this point. If you exert a force in this manner, it will move in this direction. So the body will rotate in this direction, and then this torque, since it is anti-clockwise, such torque is regarded as a positive torque. If you exert the force in this direction, in the clockwise direction. Such torque is regarded as a negative torque. This is the second condition for equilibrium to occur. Now let's say that we have a ball. Let's say that there is a ball. On this ball, if you exert a lot of force on this ball such that it moves, you exert forces in this manner. Okay, if the lines of force or the lines of action, line of action is a line that is parallel to the force, that is drawn from the force or parallel to the force, such that I can draw the line of action of the first force. This is the line of action of the other one, and then this is the line of action. Notice that they do not meet. It happens in this manner. They do not all meet at a point. So it occurs in this way. Now, if they do not meet at a point, if the lines of action of forces that act on an object do not meet at a point, such forces are called non-concurrent forces. And as a result, they will be able to exert a net torque on an object, which will cause the object to rotate. If net torque acts on an object, the body will rotate. And that's why we say that if the net torque is equal to 0, it is a condition for equilibrium. Now, let's say that the you exert the force in this manner in such a way that the lines of action meet at a point. In this case, this is an example of a concurrent force. These are concurrent forces because their lines of action meet at a point, and as a result, the net torque cancel out. So it means that this body will remain at rest, or it will continue to spin at a constant angular velocity. Torque is the product of force and the moment arm r. The moment arm is the perpendicular distance from the axis of rotation to the line of action of the force. The axis of rotation can also be referred to as the pivot. Let's say that this is the beam again, and then the length of the beam, let's call it L. If you exert a force in this direction, if you exert a force, the body will move in this manner. It will rotate about this point. So this is the axis of rotation. So the perpendicular distance, the line of action is the line that is drawn from the force. It's parallel to the force. So the distance from this point to this point is referred to as r. This is the force. So this is r is the moment arm. In this case, the r is equal to the length of the beam, but they are not equal. Let's say that we have a beam that looks like this. If you exert a force at a particular angle, if you exert a force in this manner, notice that it is not perpendicular to the beam. You exert the force at an angle theta. Okay, now let's draw the line of action. The line of action will be this line. It implies, and this is the axis of rotation. So the perpendicular distance from the axis of rotation will be this, such that it will be perpendicular to it. So let's say this is our r, which is the moment arm, the perpendicular distance from the line of action of the force to the axis of rotation. Okay, and then L is the length of the beam. Okay, now we need to find, don't forget that if this angle is theta, this angle will also be theta. Okay, now suppose that okay, we know that torque is the product of force and the moment arm. So we can find the r, which is the moment arm, from this diagram. So let's say this is the diagram, and this is angle theta. This is the length of the beam, and then this is the r. We are looking for r. Now we can infer that sine theta since we have the opposite, this is a right angle triangle. Since we have the opposite and then we have the adjacent, I mean the hypotenuse. The hypotenuse is the line that faces this angle. Okay, so the and then SOHCAHTOA, we are using SOHCAHTOA. Okay, now in SOHCAHTOA, the first condition is sine is opposite upon the hypotenuse. So sine theta is opposite r, the hypotenuse is l. As a result, r is equals to l sine theta. So in this case, the torque will be equal to the product of force and l sine theta. So we can also use this formula. Notice that if theta is completely perpendicular, if theta is completely perpendicular, like in this case, theta will be 90 degrees, and that's 90 sine 90 will be 1. So you will still have product of force times L, which is this formula. Now, but we can also do it in another way around. If you want to avoid the stress of bringing out this diagram, you can also do it this way. If I have this is the hinge, and then a force is exerted at this angle, at angle theta. Okay, now since it is only the perpendicular force that is able to make the body rotate, that means I can resolve this force into its perpendicular axis called Fy, and then I can resolve this force into its vertical, I mean horizontal axis, which is Fx. But the Fx cannot cause the body to rotate. So only the Fy can cause the body to rotate. But notice that if I resolve this force F into this axis, into the y-axis, then Fy will be equal to F sine theta. Okay, so if you are not sure about how I did that, you can find it. If this is angle theta, and then we have something of this nature, this is the theta, and then this is the Fy, the vertical axis, and this is the F. So we have opposite and hypotenuse, so we can say sine theta is the opposite upon the hypotenuse F. So it means that Fy is F sine theta. Okay, so the perpendicular distance is still L, so we can say that the torque is the product of F sine theta and L, which is the same thing as this. Okay, now let's solve some practice problem. Find the torque produced by 300 Newton force applied at an angle 60 degrees to the door of the figure shown below. So this is at angle 60 degrees. Okay, now let's say this is a pull upward, and then it is at angle 60 degrees. Notice that we can do it in two ways. We can do it by extending the line of force. That is, we can extend the line of force in this manner. If we extend the line of force, then we can find the perpendicular axis. This is the axis of rotation. This is the hinge. Okay, so we can find this is the perpendicular distance. So this is the moment arm. This is the distance, 2 meters. So, and this has to be angle 60 degrees because they are equal. They are opposite angles, so they are equal. So we can bring out that angle in this manner. Okay, so that we will have 60 degrees and then r and then 2 meters. Notice that this is the perpendicular sine, so that we can say that sine 60 is the opposite upon the hypotenuse, so that r is equal to 2 sine 60. So it implies that the force that is being applied The torque is the product of the force and the moment arm, which is the perpendicular axis from the axis of rotation to the line of force. So the force in this case is 300 Newton. So the product of 300 to sine 60, which is equal to 519.6 Newton meter. So since we don't have 519, we can approximate it into 520 Newton meters. And that's the answer. But notice that we can also do it by resolving this force into this axis. If I resolve that force to that axis, I will have something of this nature. We have this axis. And then if I resolve this force to this axis, I told you in my video where I talked about resolution of vectors, it will be suggested up here. Okay, I told you that if you don't have angle in here, just pick up the force and then you will have sine 60 degrees, the sine of this angle, and the force that will be the vertical component Fy of this force. That means if you resolve this force up here, you will have F sine 60, and then if you resolve this force down here to the horizontal, which is Fx, that will be F cos 60. So cos 60, because there is angle in here enclosed with it, there is no angle is enclosed with Fy, so it takes sine. So this is the perpendicular force. Perpendicular force is able to cause rotation, so we make use of this. Then the torque will be equal to F sine 60 multiplied by the perpendicular distance, which is the moment arm or the length of the beam in this case. So that would be 2. So we can have 2 multiplied by 300 sine 60, which is the same thing as 520 Newton meters by approximation. Now let's solve another practice problem. On a uniform beam of length 5 meter hangs a mass 30 kg at one end. The beam then balances at a point 1.5 meter from this end. Find the mass of the beam. Now let's say this is the beam. So if this is the beam, then it is a uniform beam. A uniform beam is a beam that has its center of gravity at its center. So if this beam is 5 meters, the center of gravity will be at the middle. It will act, and the weight will be at the middle. A uniform beam has its weight acting at its center. So that means the distance from this point to this point will be 2.5, which is the half of 5. So we can have something of this nature. Now, okay, now on a uniform beam of length 5 meters, we have done that. Hangs a mass 30 kg at one end. Let's say that there is a mass at one of the ends. The mass is 30 kg. Okay, so if we exert a mass of 30 kg, the weight of this mass will be 30 times acceleration due to gravity, since weight is the product of mass and the acceleration due to gravity, and the acceleration due to gravity in this question is given as 10, which is 300 Newton. So it implies that a 300 Newton force is acting at one of the ends. Now the beam then balances at the point. We don't know the weight of the beam yet, but we know that the weight of the beam, let's call it W1, let's call the other weight W2. The weight of the beam is the product of mass and acceleration due to gravity. So since gravity is 10, so we can have 10 m, where m is the mass of the beam. All right, The beam then balances. Notice that the distance from this point to this point will also be 2.5 since the weight acts at the middle. Okay, now the beam then balances at a point 1.5 meter from this end. Which end? This end. Is still talking about this end. From the question, the length of the beam is 5.5 and it hangs a mass 30 kg at one end. The beam then balances at a point 1.5 meter from this end, that is that same end. So we can say that, let's measure 1.5 from this end to this point. So the remaining length will be 1 meter. It balances at this point. Now the implication of that is that this is the point where we are going to have the pivots. So it balances at those points. So we are going to have the pivot at that point. At that point. So that is the point where the body will be rotating. The body will be rotating at that point. So that is our axis of rotation, or the pivots. Okay. Now, to find the torque on this body, to find the torque, okay, to find the measure of the rotation, let's first of all consider the torque that will be caused by this weight W1. Let's call it T1. The torque that will be caused by W1, that will be W1 multiplied by the perpendicular distance R. Okay, now notice that this torque will be positive. The reason is because it is counterclockwise or anti-clockwise. This is the perpendicular distance here. So this torque will act in this manner as to the balance point. Okay, so that makes it, and that direction is anti-clockwise. So it is positive. The torque is positive. Now, the torque that will be caused by this W2, let's call it T2, and it will act in this manner, in this direction as to the balance point. So that will be minus because it is clockwise. Clockwise means it is moving this in the direction of the clock. So we can say W2 multiplied by the perpendicular distance R. Okay, now the W1, we have it as 10m, where m is the mass of the beam, multiplied by the perpendicular distance as to the balance point is 1 meters. So that's 1. Okay, and that it is positive. Okay, and this is minus 300 Newton multiplied by the distance, which is 1.5. Notice that the sum of the torque, for us to have an equilibrium, the sum of the torque has to be equal to 0. So the implication is that the product of 10m and 1, which will give us 10m, then plus the other torque, which is minus 300 times 1.5, that is 450. It has to be equal to 0. That is T1 plus T2 must be equal to 0. That's the sum of the torque. So it implies that 10m minus 450, it must be equal to 0. So I can say that 10m, by adding 450 to both sides, or by taking 450 to the other side, we can have 450 in this case. So that the mass of the beam will be 450 divided by 10, which is equals to 45 kilogram. Okay, let's solve the next practice problem. A box is suspended by a rope when a horizontal force of 100 Newton acts on the box. It moves to the side until the rope is at angle of 20 degrees with the vertical. The weight of the box is what? Now let's say that this is a ceiling in which there is a box that is being attached. The weight of the box is given as capital letter mg, and then this is the mass. Okay, now anytime you have a rope attaching a mass, there will be a tension on that rope. The tension is the force that helps the mass from falling down. The acceleration due to gravity, the weight of the object is acting downwards, but the rope is pulling the object upwards so that it will not fall due to gravity. As a result, the direction of tension is always upwards. That is, the direction of tension is towards the pull of the object, so is upwards. Now, the after some time, a particular horizontal force was exerted on the object, so the object will appear in this manner. So this will be an imaginary dimension, which is the initial position. So the object is now at this point. Notice that after the force after the force has been exerted on the object, it moved until it forms an angle of 20 degrees with the vertical. This is the vertical axis. Okay, and then this is the tension which acts upwards, and then the weight of the object which always acts downwards. This is the horizontal force. Let's call it F. Okay, now in order to solve this problem, I would like to draw a free body diagram to represent this scenario. In a free body diagram, you represent the mass as a point, and then you draw 4 cardinal points around the mass of that object. The free body diagram will help us to know the forces, the external force that causes motion for that object. So in a free body diagram, only external forces are recorded. As a result, the weight of the object acts downwards, that is along that axis. Okay, the free body diagram will make it simpler for us to solve this problem. And then there is an horizontal force F along this direction. Okay, notice that there is tension which is at 20 degrees to the vertical axis. So this is the vertical axis, so it is at 20 degrees. So let's say this is the 20 degrees. So the tension acts in this direction, tension T. Okay, now in order to solve this problem, we will need to use the first condition of equilibrium. That is, for this mass to be in equilibrium, the net force has to be equal to 0. That means we can resolve the force on the x-axis to be 0. The net force on the y-axis has to be 0. The net force on the z-axis has to be 0. Now, in this case, we need to resolve this tension into the horizontal component, that is Tx, and then we need to resolve it into its vertical component, that is Ty. Okay, notice that the sum of the forces on the x-axis will now be equal to Tx plus F, and it has to be equal to 0. Okay, notice that Tx is in this direction and Ty will also be in this direction, so Tx is negative. Also, the sum of the forces in the y-axis, which is positive, plus Ty, because that is along the positive y-axis, then plus the weight. Notice that the weight is negative because it is along the negative x-axis, so we'll have minus the weight. It has to be equal to 0. We have nothing on the z-axis, so we can just erase that, since we are considering a two-dimension diagram. A two-dimension diagram consists of the x and y, three-dimension x, y, z. So we have something of this nature. Now, what is Tx? Tx is T, that is T, that will be T sine 20 degrees. I already explained why this is sine 20 degrees. that's t sine 20 because there is no angle here. Then ty will be equal to t cos 20 degrees. Okay, so we can say that the net force on the x-axis is equal to minus t sine 20 plus the force. The force is 100 Newton, the horizontal force, and it has to be equal to 0. Okay, and then on the y-axis, the summation of the forces on the y-axis, which is plus ty. In this case, ty is t cos 20 degrees, and then minus the weight of that object, and it has to be equal to 0. So from this equation, we can infer that the weight is equal to t cos 20 degrees. So I need an expression for t to be able to find the weight. I got this equation by taking minus w to the other side of the equation, or by adding weight to both sides. So from the equation of the x-axis, it implies that t sine 20 is equal to 100 by taking minus t sine 20 to the other side of the equation. So it implies that tension T is equal to 100 divided by sine 20. That is, by dividing both sides, I divided both. So let me just clear this diagram. So T is equal to 100 divided by sine 20. I got it from this diagram, from this equation. The equation which says T sine 20 equals to 100. By dividing both sides, divide both sides by sine 20, so that sine 20 cancels out, so that t is equal to 100 upon sine 20. If I substitute this equation into this equation of weight, notice that the weight will now be equal to t, where t is 100 upon sine 20 multiplied by cos 20. As a result, we can do this with the calculator. 100 multiplied by cos 20, okay, divided by sine 20, okay, that's equal to 274. Okay, that's 274.7, and that's supposed to be in Newton. All right, so that is the weight of the object. Let's solve another practice problem. A 100 kg box is suspended from two ropes. The left will make an angle of 20 degrees with the vertical, and the other make an angle of 40 degrees. What is the tension in each rope? Okay, let's say this is the box. Okay, the box is being suspended by two ropes. Let's say these are the ropes. Okay, now the left side of the rope, which is this one, exerts 20 degrees to the vertical. So this is the 20 degrees, and then the other one exerts 40 degrees to the vertical axis. So that's 40 degrees to the vertical axis. Okay, since this is the vertical axis. Now don't forget that this body will exert its weight downwards. Since the mass of the body is 100 kg, so we multiply it by 1000 to get the weight. We multiply by 10 to get the weight. so that the weight becomes 1000 Newton. Now let's draw the free body diagram. This is the mass, so we need to have four cardinal points around it in order to express the forces that causes the body to move, so that the weight acts in this manner. Let's say W, and then we have the tension T1. It will act upwards. I already told you the reason in the last practice problem. And then this is T2. Now T1 acts 20 degrees to the vertical, so we have 20 degrees here, and then this is 40 degrees to the vertical. So I can resolve T1 into its horizontal component, that is T1x. I can resolve it into its vertical component, that is T1y. I can resolve T2 to its horizontal component, that's T2x. I can resolve it to its vertical component, that's T2y. Notice that T1x will be T1 sine 20, while T1y will be T1, okay, that will be T1 cos 20 degrees, and then T2y will be T2 cos 40 degrees. I already told you the reason in the last problem. And then this will be T2 sine 40 degrees. All right, the weight is along the y-axis, negative y-axis. Now let's find notice that for that body to be in equilibrium, the summation of the force, the vector summation of the forces, has to be 0. So we get to find the summation of the forces along the x-axis, and then the summation of the forces along the y-axis, it has to be 0. Now along the x-axis, we have T1x plus T2x, which has to be equal to 0. T1x plus T2x, it has to be equal to 0. Notice that the implication of this is that T1x, which is along the negative x-axis, will be minus T1 sine 20, which is plus, okay, plus T2x. T2x is along the positive x-axis, that's T2 sine 40, it has to be equal to 0. So we can simplify this equation further by saying T2 sine 40 is actually equal to T1 sine 20. That is, by adding T1 sine 20 to both sides, or by taking T1 sine 20 to the other side. So it implies that T2 is equal to T1 sine 20 upon sine 40. That is, I divided both sides of this equation by sine 40 in order to obtain T2. Now notice that sine 20 divided by sine 40, okay, sine 20 divided by sine 40 is equal to 0.532. So that we'll have T1 0.532. Okay, that means T2 is equal to T1 multiplied by 0.532. So this is an equation. Let's call this equation 1. Now let's say that let's consider the y-axis now. The y-axis, it has to be equal to 0, and that should be T2y plus the weight of the object. It has to be equal to 0. Oh, plus three things. We have three things on the y-axis. Yeah. We also have We also have T1y. So it has to be equal to 0. Okay, we know the weight of the weight is negative. Okay, the weight is negative, so it has to be negative. The weight is negative, while these are positive. In this case too, the T1x is negative. I did it here. I actually put the negative sign here. So, but I didn't put it here. So it's negative. The summation has to be 0. So now, what is T2y? T2y is equal to T1 cos 20 degrees minus the weight of the object, which is 1000, plus T1y. T1y, oh, T1y is T1 cos 20. Okay, and then T2y is T2 cos 40. So we can have T2 cos 40 equal to 0. So it implies that I would substitute the value of T2 into this formula so that I will have something of this nature. T1 cos 20 minus 1000 plus, instead of T2 now, I'll have T1. I'll have T1, then 0.532, 0.532, then cos 40, which has to be equal to 0. Okay, so where this is our T2, notice that we can simplify the equation further so that we will obtain something of this nature. T1 cos 20 can be equal to, okay, T1 cos 20 plus, we can multiply cos 40 by 0.532. 0.532 multiplied by cos 40, that will be equal to 0.407. So plus 0.4075. Now it implies that, let's have cos 40, cos 20, cos 20, cos 20 is 0.9396. So we can have 0.93969 T1 plus 0.4075, then T1, that's equal to 1000. So by adding these two together, that's 0.93969 plus 0.4075. So we'll have 1 point. Okay, let me cut off, let me create a space here. Okay, if we add the T1s together, that will be 1 point, that will be 1.3472 T1, which is equal to 1000. So 1000, so it implies that T1 is equal to 1000 divided by 1.3472, so that T1 is equal to 1000 divided by that answer, so that I will have 742.28 Newton. So we can also find T2. Recall that T2 is equal to T1 multiplied by 0.532. So that T2 will be 0.532 multiplied by T1, which is 742.28. As a result, we'll have 0.532 multiplied by 742.28. So that's T2, which is the second tension, that will be 394.893 Newton. So these are the tension on the rope. Let's solve the next practice problem. The wheel of a certain bus are 2 meters apart and the bus falls over when it is tilted sideways at an angle of 45 degrees. How high above the road is the center of gravity? Now, let's say this is the ground and then the wheels, which are 2 meters apart. Okay, so they are 2 meters apart. Notice that the center of gravity G, let's represent that with G, okay, will act vertically downwards always with, let's say it's at height H from the ground. Now, so when you tilt the car, if you tilt it at an angle of 45 degrees, if you tilt it at an angle of 45 degrees, okay, this used to be, okay, let's have 45 degrees here. Don't forget the distance apart is 2 meters. Okay, the center of gravity G will act in this direction because you have just tilted it. It will act in this direction, but the initial center of gravity is along this manner. So we can say that we can make use of the one that is vertically downwards, which is this H. We have this because we tilted it at an angle of 45 degrees. So the center of gravity will also shift from this point to this point at 45 degrees. Notice that this G, this H, this one, okay, let me use the green now. Notice that this is this one. And then due to tilting at an angle of 45 degrees, it will affect the center of gravity so that it will be tilted in this manner as well. For instance, let's say we have a box. Let's say we have a box in this on a surface, on a flat surface. The center of gravity G will act downwards in this case. Now, suppose that you tilt the ground. You tilt it from the ground at an angle of 45 degrees. The box will now be located in this manner. Notice that the first G that you have, it's like this to the ground at an angle, at an height of H. But because you now have it tilted, the center of gravity will not act in that direction. It will be towards this manner at 45 degrees. So it has been tilted by 45 degrees. So we can bring out this triangle so that we will have something of this nature. Height H and then angle of 45 degrees, and then don't forget that this is 1 meters and this will also be 1 meter, so we can have 1 here. We can make use of the tan of theta. That means from SOHCAHTOA, the TOA is opposite upon the I put adjacent. So the opposite that we have in this case, okay, opposite upon the adjacent, so that tan 45 degrees, which is equal to opposite, which is 1, upon the adjacent, which is h. It implies that, okay, so we can cross multiply so that h tan 45 degrees is equal to 1. If you divide both sides by tan 45 degrees, tan 45 degrees, you will have something of this nature. H is equal to 1 upon tan 45 degrees. But notice that tan 45 degree is equal to 1. So that we'll have 1 upon 1, which is 1 meters. Alright, so that is the height of the center of gravity. Alright, so make sure you watch the next video where I'll continue to solve some other practice problems. And subscribe to this channel. Share with your friends as well.